And let's take a look at number 36 here in 3.3. First thing I want to notice is the notation that they used in this problem. They used that ddx notation that people usually don't like that much. Remember, guys, that when you see ddx, it's an operator. It means take the derivative of everything that comes after it. So never, ever, ever in your life will you see something that looks like this. ddx equals, 5x minus 3 or whatever you got, because ddx needs something after it to tell you what you're taking the derivative of. So that's just the first thing I wanted to notice right here, and that's why I put an equal sign at the end of this line here. Unlike the previous problem I just did where we were given this right here, f of x is equal to a function, so then on the next line you want to begin your derivative with f prime of x equals. All right, guys, so in this problem right here, again, we're in 3.3, we're practicing the product rule. We're going to do the product rule here because we have a factored expression. Here is our first factor, which we might call u, being multiplied by our second factor, which we might call v. So let's go to the product rule. Now, guys, if I had the room, I would just start writing my answer right here and try to do everything on the same line. I don't think I have room for this one, so I'm going to put an equal sign down here, but really, ideally, this would just be one long line right here. Okay, our derivative then is going to be our first factor, which is ax plus b, multiplied by the derivative of the second. Now remember here, guys, it said in this problem, a and b are just arbitrary constants. X is the only variable here, which I can tell because we're taking the derivative with respect to x. Okay, so the derivative of abx squared, we're going to bring this 2 down, multiply it by the existing coefficient. So that is going to be a 2ab multiplied by x, and now we drop our power by 1, so that's x to the first. But of course, we don't usually bother writing that 1 right there, and there we go. And then plus, well, the derivative of 1 would be 0, but again, we don't bother writing that ever. So that's what we've got right there, guys, 2abx for the derivative of v. So that's the first half of the product rule, u times the derivative of v, plus the second factor, v. So that's going to be abx squared plus 1, not changing this at all, times the derivative of u. And the derivative of ax plus b is just going to be a. That is a linear function right there, guys, so the derivative is just your slope. So again, this answer that I have right now is going to get you at least half the points here, guys, on a test or quiz question. The rest of the points would come from simplification. So looking at what we might be able to do here, I kind of think that if I were to distribute this 2abx backwards into this binomial, I think I might end up with like terms here that I'm going to be able to combine or maybe even cancel. So I'm going to try distributing and see what happens here, guys. This times this here is going to get us a 2. There's an a times a in there, which is an a squared. There's a b, and then x times x, which is going to be an x squared. That's kind of ugly. And then plus, now the 2abx times the b is going to get us a 2ab squared x. Gotcha. And then over here now, guys, the a times the abx squared is going to be a squared bx squared. And then plus the a times 1 is just going to get us an a. So, yeah, I believe that right here and right here, we have ourselves two like terms. Let's double check that. They both have a squared, they both have b to the first, and they both have x squared. So those two terms can be combined just by adding their coefficients. The 2 and the 1 here is going to get us a 3. A squared b x squared. And then I've got two other terms right here that aren't alike with anything else, so they can't be combined. So I'm just going to write that as plus 2ab squared x, and then a plus a. And guys, for my money, that I think is the best answer we could come up with here to this question. I do suppose it would be possible, not advisable, but possible, to realize that these three terms have a common factor of a, so you could factor that out and make it 3abx squared plus 2b squared x. Don't forget now, guys, there'd be a plus 1 at the end of that. So I would absolutely give full credit for that answer as well, but I really don't think we've gained anything by factoring out that a, so I really like this version of the answer right here in the box. I didn't get a chance to check this answer just yet, but I think that one is correct. If it's not, I'll come back and add something to this.